In this lesson, we will use the law of uninhibited growth to solve an application. The law of uninhibited growth. The number of organisms n at any time t is given by the formula n of t equals n naught times e raised to the kt, where n of 0 equals n naught is the initial number of organisms and k is greater than 0. Note the similarity to a of t equals p times e raised to the power rt, where instead of the number of organisms, we were determining the amount of money. Let's look at an example. The population of the state of Utah in 2000 was 2.245 million. In 2010, it was 2.776 million. If the population of Utah continues to follow the law of uninhibited growth, what will the population be in 2025? I like to set up a chart to organize the details, and here I have the year and the population in millions. In the year 2000, the population was 2.245 million. In the year 2010, the population was 2.776 million. And in the year 2025, we don't know what the population will be. That's what we're trying to determine here. Okay, so I add a third column for t, where t is the number of years after the year 2000. In the year 2000, 2000 will be 0 years after the 2000, so t equals 0 here. 2010 is 10 years after the year 2000. 2025 is 25 years after the year 2000. Next, we want to determine k for n of t equals n naught times e raised to the power kt. To do that, I will set n naught equal to 2.245, and I will look at the year 2010 when I know that t is equal to 10. I will let n be equal to 2.776. So n is 2.776. In the year when t equals 10, I have n naught of 2.245 in my formula. And I will start by dividing through by 2.245 to get 2.776 over 2.245 equals e raised to the power 10k. I will then take the natural log of each side. And I see that the natural log of e raised to the power 10k is 10k. Multiplying both sides of the equation by 1/10, I have k is equal to 1/10 times the natural log of 2.776 over 2.245. Okay, so next we want to solve for the population in 2025. So I'm going to let t be equal to 25 now. N naught is still 2.245, and n will be my population in 2025, so that n is what I'm trying to find here. I also found k, so I know what k is. I know what all my values on the right-hand side of the equation are. I'll plug those in. So n, the population in 2025, will be equal to 2.245 n naught times e raised to the power of k times a t value of 25, where k equals 1/10 times the natural log of 2.776 divided by 2.245. Plugging that into my calculator, I find that n of 25 is approximately equal to 3.817. This can be summarized as the population of Utah in 2025 will be approximately 3.817 million, or 3,817,000. Try on your own. The population of Salt Lake City in 2000 was 181,779. In 2010, it was 187,082. If the population of Salt Lake City continues to follow the law of uninhibited growth, what will the population be in 2030?